Okay, so these are what? These are the chapter checklist. We will discuss about these three topics: charged particle in matter, your distribution of electron in different shells, different orbits, and the last one is atomic number and the mass number. Now, how to represent atomic number, Razi?
Ma'am, is that ma'am, atomic mass unit same?
Hmm?
Ma'am, AMU
No, I'm asking about representation. How to represent this atomic number and there's the alphabet, right? To represent these two? No? Yes, sir. How to represent this atomic number?
ma'am, like the letter
Atomic
for
number, ma'am, atomic number, what it's A, I mean Z.
It's Z. And mass is A, right?
A.
E.
So this is the representation. Now we will start. In the structure of atoms, we have already discussed some of the things. What is atom shape? Atom shape is spherical, we can say. Okay. And atom is what? Atom is smallest, invisible, indivisible, or we can say indestructible. Okay. So here, this is what? This is a sodium atom. In this box, there is a lots of what? Na atoms. So what is subatomic particles? Subatomic particles is what?
protons, neutrons, and electrons.
The particles which is present inside an atom, right? Inside an atom, which is neutrons, protons, and electrons. Now you all tell me what is the charge of neutron, and proton, and electron. Arham, not you.
Ma'am, neutron has no charge on it, proton has positive, and electron has negative charge.
How much?
Ma'am, I don't remember exact. Ma'am, is it like, ma'am, something like 1 into 10 raised to the power something?
There is like
Ma'am, 10 raised to the power 19 or 16. Yes, ma'am.
Yeah. And electron is negative.
Yes, ma'am.
Negative this whole thing, right? And what is C?
The same thing, but negative.
And what is C?
C.
Why I'm writing C over here?
Ma'am, can I tell?
No. Razi, you tell me.
I don't know.
You don't know? Okay, Advika.
Ma'am, like C, ma'am, C for like, ma'am, the name of what element it is, or like that.
Element. Okay, now what
Ma'am,
happened?
like, ma'am, it's a ma'am, C
Ma'am,
is
it's
like,
column.
ma'am, symbol for carbon.
Carbon? No. It's column.
Column.
Column is what? SI unit to measure charge.
Charge.
It is the SI unit of charge, okay? So as we already discussed that mass of proton, we always use these two masses, no? Mass of proton and mass of neutron. We never use mass of electron because this is very small. Around how much?
It's like super small. I don't remember the exact number.
Okay, like 9.1 into 10 to the power minus 31 kg. Okay, and here, what is the mass of these two? Mass of proton and mass of neutron, which is equal 1.67 into 10 to the power minus 27 kg. Okay, so you have to remember this, that
But also electron mass is so small that we can just neglect it.
yes, it's minus 31. Very small. No? So proton is 1.6 into 10 to the power 19 C, and proton and neutron mass is this much. Mass always in kg, and your charge is always in C column. This is the SI unit to measure charge. Now, what is next? Now, can you tell me I am not you. Can you tell me the discovery of neutron, protons, and electrons? Who discovered this discovery? Advika, you or Razi, anybody?
Mom, is it J.J. Thompson for like
Ma'am, is it
electron?
James Chadwick?
Or
Ma'am, I remember James Chadwick discovered something, but I forgot what he discovered.
okay, for electron, J.J.
Mom,
Thompson.
I think yes, ma'am. J.J. Thompson, I think.
Correct, only. And for proton,
Ma'am, is it James Chadwick?
no, he's for neutron.
Ma'am, I remember, ma'am, for protons, the name of something. Ma'am, it's not from R.
Okay.
Ma'am, that's all.
Rutherford.
Yes.
Okay. And do you know what is the another name of these three?
Ma'am, subatomic particle.
No, for proton and for electron. There's no name for neutron. Only for these two there's name. So for proton is what? Any idea?
Ma'am, I remember you were telling us, ma'am, I remember they were very close to the nucleus. That's why only they two were termed.
Ma'am, J. Chadwick discovered what?
Neutron.
Okay, ma'am.
Okay, so
Oh, ma'am, nucleons. Ma'am, nucleons.
who? Nucleons?
Yes, ma'am. For neutrons and electrons, it's collectively nucleons, right?
Yeah. But the another name of your proton is canal ray. We can also call proton canal ray, and we can also call neutron cathode ray. Okay. So these are the two different names of protons and electrons. Got it? Clear?
Yes.
Okay. So these are what? These are the charges. The discovery, another name, and these are the SI units. Now, in the center of in the center of atom, what is there?
Ma'am, nucleus.
Nucleus. And inside nucleus,
Ma'am, neutrons and protons.
and where's electron?
Ma'am, they're like in shells around the nucleus.
Yes, electron revolves around the nucleus.
Nucleus.
Now let's discuss about atomic number and mass number. So this is somewhat structure of atom. This is what? This is your nucleus. Inside nucleus, let's say like this, and these are the like lots of shells, or we can say lots of orbits. Here, what is there? Here's your electron revolving around the nucleus, right? Now let us just let's discuss about atomic number and mass number. So atomic number representation is Z and mass number representation is A. Now I'm writing, let's say I'm taking example of Na, which is sodium, okay? So here your number of electrons is always equal to number of protons. Correct? And what is number of neutron, or we can say number of proton in sodium? It's how much? 11, right? Okay.
Yes, ma'am.
Yes. And number of neutrons may or may not be same. Number of neutrons may or may not be
Same.
same. So here it can be like, we can say it can be 12 or anything, but this neutron is not equal to electron and proton. These two are only equal to each. Got it? Now next, here atomic number and the mass number. In this atomic number, it is what? It is the total number of electron or proton present in atom of a given element. What? Total number of electron or proton, which are always equal to each other, present in atom. So we can say number of electrons, or we can say number of protons. E minus and P always plus. And what about mass number? Mass number is the addition of neutrons and next one. Next is what? Number of neutrons plus
Protons.
yes, protons. So Np plus and N plus. So here your sodium number of electron is equal to number of proton, but number of neutrons may change. And in the mass number, it is what? It is the number of neutrons plus number of protons. So we already got number of neutron is how much? Number of neutron is how much? 12. And what about number of protons? Number of proton is 11 plus number of 12 is 12. So the total number of mass number of sodium is 23, correct?
Yes.
And we always represent this as like, so this is the representation of sodium. In the below, there's what? There's number of proton. Here is your mass number. Okay, so now you tell me, let me give you one question about carbon. Now you find this about carbon, number of electron, number of proton, number of neutrons, and mass number and atomic number. Come on, fast. About carbon and one for potassium also. Okay, 2 elements.
Ma'am, what should we tell them?
You have to find mass number and atomic number of these two.
Okay, yes, ma'am.
We need to find mass number for both of them, right?
Yes, mass and atomic both. Yeah, mass.
My atomic number is 6, right? For carbon.
I don't know. You have to find it.
Got it. Then I got it for carbon.
Okay, potassium.
Ma'am, I'm done.
Okay, we'll wait for others.
Okay.
Yeah. So what about Razi, Advika, got it?
Ma'am, for carbon, ma'am, the atomic mass is 6 and the mass number, ma'am, I'm not sure, ma'am, is it 12?
For carbon, your mass number is what?
Ma'am, mass number is 12 and atomic number is 6.
And atomic number is 2.
Ma'am, I got atomic number 6.
Okay, atomic number is 6. And
Ma'am,
mass?
Potassium, ma'am, for
As
potassium,
12.
I'm getting 40.
The potassium mass number?
Ma'am, I'm getting 40.
40. And atomic number?
Ma'am, for potassium, the atomic number I got is 19.
Okay, so how to find this mass number? Mass number is number of protons plus number of neutrons. Number of protons,
Yes, ma'am.
number of neutron. And what is the number of proton of potassium? Proton is how much?
I think I may have.
Arham,
Yes, ma'am.
what are you doing?
I think this Cortana just came.
Okay. So what is the number of proton?
not
See, we discussed now that number of proton or number of electron is your atomic number. So what
Hello,
is your
ma'am.
atomic number here? Your atomic
Hello.
number 14.
Hello.
Yeah.
Ma'am, sorry, ma'am, I dropped out. Ma'am, so, ma'am, I got confused on finding the atomic number, ma'am. So I couldn't
Okay.
find
So atomic number is what? Number of protons plus number of neutrons.
neutrons. Yes, ma'am.
Your atomic number, we can say it's a number of proton or number of neutron. So here we already got your atomic number is 19. So in the proton one, we can write 19. And what is the number of neutron? Number of neutron is 21. So total it will be 40. And number of proton or number of electron together is atomic number. So we can directly write it from here that your atomic number is 19. Okay. So if you find mass number, then it is easy for you to find atomic number because number of proton is nothing but your atomic number only. And what about carbon? Carbon number of proton plus number of neutron is 6 plus 6. So it is what? 12. Now, okay, one more. What should I give? Okay, for Al.
Ma'am, for aluminium, ma'am, the atomic number is 13.
Okay, and your mass?
Ma'am, I'm still calculating. Ma'am, the mass number is 27.
Yes, correct. 27.
And I'm also getting that.
Advika, you also?
Yes, ma'am. No, ma'am, I'm still a little bit confused about how to do it.
Okay, wait. See, first of all, we will talk about your mass number.
Yes, ma'am.
So mass number is what? Number of protons.
Plus, ma'am, number of neutrons.
Plus number of neutrons.
Protons plus neutrons.
Neutron.
And this we are finding mass number. So what is number of proton here? So we already know the atomic number. Atomic number we all know. Atomic number of aluminum is what? 13.
13.
30.
See, atomic number is what? Number of neutron or number of proton. So here we already got that your number is proton is how much? 13.
13, ma'am, because that's the atomic number.
And what is your number of neutrons?
And that's also 13?
No, that's not 13. Total mass of your aluminium is 27. So if
Yes,
you will,
ma'am. Ma'am, we have to memorize like the number of the total mass.
yeah, we have to. So it will be 7 like this. Okay.
Okay, yes, ma'am.
Now any confusion in number of proton? How to calculate number of protons?
No, ma'am.
Okay, good. Okay, now let me ask you guys one question that Aram, you will not answer. Okay, that whole number of atom is supposed to be concentrated at center. True or false? Your whole mass of atom is what is supposed to be concentrated at center. Is this statement is true or false? Or if true, you have to give reason, or if false, then also you have to give.
I think it's true because, ma'am, the neutron and the proton have like the major mass of the atom, and they're present in the center of the center of the atom, which is the nucleus, and the nucleus like attracts the electrons towards itself. So whatever the weight the electrons has is like concentrated towards the center.
Okay. Razi, what about you?
Ma'am, I also think the same. Yeah.
Same? Okay, Aram?
Yes, ma'am.
Mom, I got the same.
It's correct because your in the center of your atom there's a nucleus which consists of neutrons and protons. So these two are having maximum number of what? Your mass. So all the mass of atom is concentrated at center only. Now next question, that atoms are electrically neutral or no? Atoms are electrically neutral or
Ma'am,
not?
they are, ma'am, because like the number of neutrons is like neutrons have no charge in it, and protons are equal to the number of electrons, so the charges cancel out.
Okay, so for you they are yes. For Adham?
Ma'am, but like in some cases, ma'am, when there's change of like when two atoms are getting mixed with each other to form a molecule or reacting with each other to form a molecule, ma'am, then they're not electrically neutral, ma'am, because like the electrons change position.
Okay, let's ask others. Adham?
But like
How?
yes, they are. They are.
How?
And because like if it's stable only, but like because the same number of protons as there are neutrons. So I mean, same number of protons as there are electrons, and the charge of electrons and protons are the same. So so that's why. But it also could it. But if it's not stable, then it could also.
Yes. So here, let's say your electron is having 11 charge. Your proton is also having 11 charge, and your neutron is 12, and it's having how much charge? 0 charge. So here, only these two are having some charges. Huh? Your proton and your electron. So your net charge will be how much? 11 electrons and 11.
11 electrons,
Will be
11 protons.
zero.
Ma'am, basically 0, right?
Yeah. So in any atom, the number of electron is what? Number of proton. Hence, the overall charge will get cancelled. So you're electrically new.
Yes.
Okay. Now let's go to these notes. So what is this structure of the atom? We have learned that atoms and molecules are the fundamental buildings of block of matter. Yes, it is fundamental building. The existence of different kinds of matter around us is due to the different types of atoms and molecules present in them. Correct?
Yeah.
Yes. So Dalton assumed that atom is indivisible. Means it what is the meaning of indivisible? Indivisible means
Ma'am, that it can't be
Ma'am, it
broken
cannot
down
be
into like
divided
more
into-
subparticles.
but
Ma'am,
atom,
but it can be broken down, right?
it can be, yes, it can. So here, but a series of experimental evidences reveal that an atom is not the smallest particle. Some other particles smaller than the atoms are also present, which are known as subatomic particles, which are your electrons, your protons, and your neutrons. Okay, your atom is not the smallest particle. Your subatomic particle of an atom is the smallest particle, which is classified into three types: your electrons, your protons, and your neutrons. So the atoms of different elements will have different electron, proton, and neutron. We already discussed, no, for potassium, for calcium, for carbon, for sodium, they all are having different electrons and they are all having different protons. Now, what is charged particle in matter? The particles that carry an electric charge are known as the charged particle. Okay, particles which will carry what? Electric charge is what? Is your charged particle. Generally, on rubbing two objects together, they become electrically charged. And earlier, what happened? Your early humans, they rubbed rock each other. So
Yes, ma'am.
so what happened then?
Ma'am, to like light up anything.
What?
Ma'am, to light up anything.
Fire. So that's how on rubbing two objects each other, your thing will get electrically charged and your electrons will flow from one place to another place. So it means that some charged particles are present within the atom. In your atom, there are some charged particles which are present. Now, discovery of electron. So who discovered electron? Who?
Ma'am, J.J. Thomson.
Yes. So it was known by 1900 that the atom was not a simple indivisible particle but contained at least one subatomic particle, the electron. Okay, he only discovered about electron. J.J. Thomson. He thought that atom is not a small particle. There's one more small particle which is only electron.
Yeah.
So electron is also another name of electron is cathode ray. Okay. In the experiment, a gas at low temperature was taken in a discharge tube. He took what? He took a gas at a very low temperature in a discharge tube, which is made up of glass. Your tube is made up of glass, and in that glass, he took a gas, which is at very low pressure. So at the end of the discharge tube, two electrodes were placed. So at the end means, let's say this is my electrode. So at the end of the discharge tube, two electrodes plate metals, maybe like this or like this. He placed two metal plates were placed connected to a battery. Now these two metal plates are connected with some battery. For a battery which is of very high voltage, the electrode connected to the negative end, that is known as cathode, and the positive is connected to the anode side. Your negative thing is connected to, like, the electrode connected to the negative end was known as the cathode and positive is known as the anode. So during this experiment, he found a beam of negatively charged particle, which is known as the rays. Which ray? Your cathode ray. As they were originated from the cathode, these negatively charged particles were called electrons. So that's how he discovered electron, by this experiment. He put first what at the in a tube. He put the gas at a very low pressure. Now in that tube, at the bottom of the tube, he placed two metal plates, and he connected that two metal plates with what? With a battery which is of a very high voltage supply, right? And then what happened? The electrode is connected to your negative end, which is known as cathode, and positive is connected to the positive end, which is anode. So here, what he found a beam of negatively charged particle, which is known as the rays, but which originate from the cathode side, means from your negative end. So that's how your electrons discovered. And what is the charge of your electron? This negative charge is your electron. Why? Because now why your charge of electron is negative?
Ma'am, because it was found from the cathode rays.
Yes. And another name of electron is also your another name of your electron is also cathode ray. Now understood? Clear?
Yes, ma'am. Yes, ma'am.
Okay, Arham, got it? Good. What is the next thing we will learn? Okay, we will learn about proton. Now, who discovered proton? Okay, in some book, there's, okay, here I wrote what?
Ma'am wrote a code.
Chadwick, no? No, sorry, yeah, rather. But here, see, let's read this. An atom is electrically neutral, but the formation of cathode ray shows that the atom contains negatively charged electrons. है ना? With that experiment, with this cathode ray experiment, what we saw that electrons are negatively charged, right? So atoms must also contain some positive. If there is some negative, there must be some positive. If there is positive, then there must be some negative. So with the discovery of that electron, who discovered electron? Tell me.
Ma'am, J.J. Thomson.
J.J. Thomson? Yeah. So J.J. Thomson discovered electron, and he found what? That a cathode ray, na? Your negatively charged electron. So he found your negative thing. So there should be some positive thing. So atoms must also contain some positively charged particle to balance your negative charge. If there's only positive charge, and if there is not any, if there is only negative charge and no positive charge is there, then what will happen? It is not balanced. Na? -2 + 2 is what? Is 0. It's balanced, right? So to balance this, we need some positive charge, which is protons. So that's the basis of discovery of proton. So before the identification of electron, your Goldstein in 1886 discovered the presence of new radiation known as canal ray or anode ray. See, the another name of proton is canal ray or anode ray. In your exams, they might ask you, what is canal ray? So don't get confused. It is only proton. It is proton. So these rays were positively charged radiation, which are seen moving from the anode side. Now your your negatively charged electrons were moving from which side?
On cathode rays.
Yes, cathode. Yeah. So the cathode side, that's why it is the another name of that is cathode ray. And here in this one, it is moving from the anode side. That's why the name of this is also an anode ray from a positive charged particle. Okay, towards the cathode, see, your radiation which are seen moving from the anode towards cathode means from positive to negative. In your discharge tube, when a high voltage is supplied through electrode, there also it's the same. Here also only the protons is from here to there. So porous cathode is used to provide the path for passing anode ray, which this cathode is used to provide for passing this positively charged electron. It led to the discovery of your protons, which is what? Which is plus 1.6 into 10 to the power minus 19 column. And it is considered as plus 1. And the mass of proton is this kg. The mass of proton is approx 2000 times as that of the electron. Okay, means the mass of proton is very high. Okay, got it? So what is the conclusion? Conclusion is the mass of proton is taken as 1 unit and its charge is plus 1, whereas the mass of electron is negligible. It is -1. So it seems that an atom is composed of protons and electrons. Now they are balanced. Correct? Got it?
Yes.
Any doubt here?
No, ma'am.
No? Arham, what is cathode ray?
Cathode rays, like all the atoms contains negatively charged electrons.
Yeah.
So it'll become So some of them will become positively charged particles.
Huh?
So this bias, will be of the discovery of protons.
Discovery of proton is your cathode ray.
Yes.
Okay, Razi. Discovery of proton is your cathode ray, Razi.
No, ma'am, it's electron, ma'am, because it is negatively charged.
Arham, where are you? Discovery of proton is your anode ray, na? Because it is positively charged.
Oh, yeah.
And discovery of neutron is your cathode ray because it is negatively charged in it. Okay?
Ma'am, neutron or electron?
Yes, Razi?
Ma'am, it is neutron or electron?
What?
Ma'am, for cathode rays.
Electron? Why neutron?
Ma'am,
See?
you,
Electron.
ma'am, you just said electron, so I got confused.
Oh, okay. No, it's electron. And that's proton. Electron is minus, proton is plus. Okay?
Yes.
Cathode and your anode, or here we can also say canal ray. For anode, this is also known as canal ray. See here I wrote canal. Okay, so that's it for today. In the next class, we'll discuss this structure of atom, your Thomson model, and what's next. Next is your Rutherford model. Okay?
Okay.
Okay, bye.